Another idea was electro-osmosis. If you've seen some of my other videos about settlement, you know that it's hard to get water out of clay. And there are quite a few clever ways engineers use to make it happen faster. One of those ways involves inserting electrodes into the soil and passing electric current through it. Clay particles have a negative surface charge, so the majority of the ions in the water between the particles are positively charged. Electro-osmotic consolidation takes advantage of this by applying a voltage across the soil, causing the water to migrate toward the cathode, where it can be pumped to the surface. The idea seemed promising because by carefully choosing the location of electrodes, engineers hoped they could selectively consolidate the clay below the north side of the tower, reducing its overall tilt. They even performed a large-scale field test near the tower to shake out some of the kinks and gather data on the effectiveness of the technique. But it didn't work at all. Turns out the soil was too conductive, so things like electrolysis, corrosion, heat, and all the other effects of mixing electricity and saturated soil made the process pretty much useless for this particular case. So the committee was down to one last idea: underexcavation. If they couldn't get the soil below the tower to consolidate, they could just take some out. And again, they would need to test it out first. So in 1995, they built a large concrete footing on the piazza grounds not far from the tower. Then they used incline drills to bore underneath the footing and gradually remove some of the underlying soil. Guide tubes kept the boring in the right direction, and a hollow stem auger inside two casings was advanced below the footing.